or grab dice or get with a partner who has dice already. So you really should be in a team. So there's no research pages or anything. Yeah, make sure you got your notebooks. You're good. We were really just going over homework problems. Hey, Aubrey. Find your relate, but quit distracting other people. Just get on with what you need to. So today we're going to talk about probability tables. And yesterday we kind of started this because we wanted a model to represent like what we were talking about. So we kind of went ahead and made our own tables, even though it didn't tell us that we had to. We chose to. So anyone feel like reading? No. Want to read? Marvin, go ahead. Read that. As you may have noticed, that paragraph.
As you may have noticed, less than 5.23 there is a probability more than one event, more than two possibilities for each event. And then the rocket decision is when keeping track of all the outcomes count. And this lesson you will learn about probability tables, look at it, this time, organizing all the possibilities.
So, again, we're here to make your life easier. This is a strategy to organize all possibilities of a game. So, in your notes, let's go ahead and I'm going to drag this back down here to make sure anyone watching the video gets the homework. But let's get a header. So, if you have yet to do this, 524, probability tables. So, let's head our notes if you haven't done that yet. And you can abbreviate if you want. So if you can remember that PROB is going to be probability, that's fine. So a probability table is going to organize all outcomes. So yesterday when we talked about rock, paper, scissors, how many possible game results were there in rock, paper, scissors? Alex? 9, right? Because we can go rock, 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 paper, rock, scissors, and we can keep looking at all those different options. So, 10 O's is the game we're going to start with playing today. So in this game, we're going to create a strategy, play a board game based on your predictions of likely outcomes. You will place 10 O's on a number line. Then we will roll 2 number cubes and add the resulting numbers. As we roll these number cubes, and I'm probably going to... Hey, ladies, can we chill? Can we handle ourselves? So the decision was, do I have them on laptops using fake dice, or do I let them have real dice? Don't make me regret my decision. As we roll the number cubes and we call out the sign, and you guys might just do this on your own, we're deciding, we'll cross out an O over the number called. So whatever numbers we get, we're going to get rid of. Right? So why do I have this number line right here? Why do I have 1 through 12?
On 2 dice, because that's how many numbers you can get on 2 dice.
Yeah, on 2 dice, if I'm going to add up a 6-sided and 6, the most I can get is 12. Okay, so draw this number line in your notes. If you want to write that we're on problem 554, please go ahead and notate that. I'm going to swap screens real quick. Now, thanks to my problem with commitment, I only bought 1 of these giant die, even though there were 2. So here's my plug. If you ever find one of these out in a store that's like under 20 bucks probably, buy it. I'll pay you back for it. I found this at like Marshall's or one of those weird, like they have all kinds of random stuff places. There was a second one, then I went back the next day and it was gone. So I have 1 of those and 1 of these to roll for our together. So if we have time, we'll come back and you guys will do this on your own. So you have 1 through 12 up here, right? Anyone want to make some predictions? If you've played a lot of board games, you want to make some predictions of what? We're going to cross out numbers as we get the sums. Marvin? Okay, Marvin says we can't get 1. Patrick?
That might be hard to get 2.
Might be hard to get 2. Okay. So actually, let's put a cross for every time we get a number. So if we get a number twice, we'll add another slash across it. So let's go ahead. We've got a 2 and a 5. What is that? 7. Put a slash through 7. We've got a 1 and a 1. We got a 2. Snake eyes. We've got a 1 and a 3. What is that? A 4. We've got, oh, 1 on reserve. We've got a lost die. A 1. All right, this is a cheater's die. This 1 has come up 3 times in a row. We've got a 1 and, gosh, stop rolling. A 2. What is that? 3. So we got a slash on the 3, a slash on the 4. We've got a 4 and a 1, which is, so that's a 5. Oh, we got a 1 and a 5. So that's a 6. So we've got a slash on 5 and a slash on 6. We've got a 4 and a 3. It's still random, even if it hits 7. We've got a 1 and a 4. So we've got another slash on 5 and another one on 7. We've got a 6 and what is it? A 2, an 8. Put a slash on 8. We've got a 1 and a 6. Ooh, another one on 7. Somebody want to help me out and do my slashes up here? You're close. Sorry, he's close. We got a 5 and a 4. Ooh, a 9. Thank you. We haven't gotten a 9 yet. I appreciate your help. I'll pay you later. Emma didn't know she was getting hired to help me teach today. So we're only missing 1, 10, 11, and 12. That's interesting. We're missing ones that are all right. Well, aside from the 1, we're missing things that are next to each other. So we've got a 2 and a 2. Okay, another 4. We've got a 1 and another 1, so we got another 2. Okay. I don't even know how many rolls we did. Did anyone keep track? I kind of got interested in what we were doing.
6, 7, 8, 9, 10, 11, 12, 13.
Okay, we did too many. We were supposed to do 10, but I got kind of caught up in what we were doing. But we got to do at least one more because 13 is just a bad number to stop on. A 2 and a 6. So we get an 8. And this is going to make it, okay. That's, no, 15s are, even numbers are better than odd numbers. Let's leave it at 14. Six. 2. Another 8. So wait, how many times did we get 8? How many times did we get 7?
3.
And we got 5 twice. We got 4 twice.
You got 4 twice.
Okay. Alright. So all we really did was collect some data there. So Gerald decides he's going to make a strategy. Thank you very much, Patrick. We're going to move on now. So Gerald's frustrated, right? He's like, what the heck is the point? Like, the teacher lost count, right? What are we doing? Why do we keep rolling these dice? So Gerald's like, forget it! I'm making a table. Some people really like tables. So Gerald tried to create a table to list all possible outcomes right over here. So check out his, here, I'll move this down onto the screen. Sorry about that. You guys can, if I forget that I'm working on the other screen, you can ask me to move it. So, check out Gerald's table. Garrett, did he list them all? If you're having trouble thinking about this, use the fact that you have two different colors of dice, right? You can start by looking at Gerald's first option. You got to name one of these cube 1 and name one of them cube 2. I like green, so green's going to be my cube 1. And set it up on your table and then think about, okay, so the next thing he has is they're both 2. Then they're both 3. Talk with your partner. Did he get all of the possible outcomes?
Obviously, this would have triples. 36 options.
Sorry, by the way, before we totally move on from this, can anyone make a general observation about results that we got more than other results? Like what seemed more likely, Grant?
Lower dice seem more likely. Also, Monopoly is a shame.
Lower dice seem more likely. Well, I don't know, these happen the most. Okay, can't get 1. But the 7 and the 8 happen the most, right? I would say the middle. But that's just me. I mean, you can go with what you're thinking. But I just was curious if anyone wanted to make an observation. Did he talk about every possible option?
No.
So, Annika, what do you think? Did he list all? Did he list all possible outcomes of rolling the 2 dice? Okay, what is he missing? Can you give me a couple examples? Okay, so we've got all of these. I like your observation. These are all the matches. And then here, we kind of switch. In this section, can anyone make an observation about what he did? Yeah.
I don't know what it's called, but so instead of going 1-1, it's 1-2. For example, you can see, but it's, I don't know, but like, okay, yeah, that.
See what Aubrey's seeing? Dice 2 is always 1 more than
Yeah,
dice 1. So there's a set right there that he looked at. What about if we look at that set? Die 2 is plus 2. Are we starting to see this, what he did?
and then it's plus 3.
And then he's got the plus 3,
Plus 0, plus 1, plus 2, plus 3.
right? So now we're plus 3. I might switch to purple for that or something.
4.
Plus 3s, plus 4s,
Plus 5.
plus 5.
So it's plus 0, plus 1, plus 2.
Okay, so did he cover all of them? Grant?
For instance, the only 6 problem in cube 1, there's only 1 instance where cube 1 has 6. So there should be.
Look at cube 1's results. What Grant's saying? There's only 1 time that he looks at cube 1 getting a 6. Can cube 1 get a 6 when cube 2 has something other than a 6?
Yes.
Okay, dude. So Gerald's frustrated, but he needs some help. So sometimes, hold on, sometimes a table where you just go down, 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 like that's not necessarily always the best. When you're working with 2 different things, sometimes we want to set up a table that goes 2 different directions. So look at, I closed my book. problem or the table in problem 56 right here. Copy this into your notes. It doesn't have to be super fancy, but copy this into your notes, and can you figure out how to fill in the rest of the table? So you might need to read the problem with your partner. You might need to read this situation. But he's going to try to fill out this table with all possible dice outcomes when he rolls and adds, just like playing Monopoly or any of those games. Not multiplication. You are correct. It is like that. What? No, I don't want to catch. I'm not an athlete. Okay, I did play tennis. I had a tennis racket somewhere. Right in high school, there was a tennis team. Oh, we were talking about the problem in my 8th grade class that I teach. They were trying to calculate the angle that the ball needs to hit the ground at in order to just get it over the net. And they did. It was good.
Yeah,
They used trigonometry to do it. Just to make sure we're all on the right track, I'm not going to fill in a bunch of this, but to make sure we're on the right track, what would go in this bottom right box?
12.
12. Thank you. Make sure we're filling this in. This is a sum table. Somebody said, oh, it's like a multiplication. It's like a multiplication table, but it's a sum table. Your axes are the results of the two die, right? So in your group, you might have green and a red, or green and a white. Whatever two colors you have, imagine I would label, actually, I can't write green and purple, that hurts me. So imagine that one of these is your one color, and the other one is the other color that you have. The two different dies. Just like we talked about the coins yesterday, a head and a head is the same, but heads and tails is not the same as tails and heads, because they're two different coins. Even if they're both quarters, they're two different coins. These are both six-sided dies, but they're different from each other. So a 5 and a 4 is not actually the same as a 4 and a 5. They're two different results. Once you think you have your table done, go ahead and look up here. Well, except mine's not done yet. Give me a minute, then look up here. You should notice a pattern. Can you tell me what I was meaning by you should notice a pattern? Alex?
The numbers go diagonally.
The results are the same if I follow the diagonal. So, notice all my 4s. Well, I can either do 3 and 1, 1 and 3, or in the middle, 2 and 2. All of my 6s, well, I could do 5 and 1, or 1 and 5, 2 and 4, or 4 and 2, or 3 and 3. Which the 3 and 3 is only one outcome. Right? So I have heads and heads on the coin. I can't like switch. Well, they're still the same. Heads and heads are the same. 3 and 3 is the same. There's not two options there. But compare to 5 and 1 versus 1 and 5. Those are two different outcomes. Even though they're the same, they're both 6. They're two different things. Are we clear on that? And now I'm like repeating myself over and over. We're trying to see how. So, let's look at some probabilities. So, as a group, I just want you to take a minute, whatever numbers you want to look at, find some probabilities from this table. So, like if you like the number 7, find what's the probability of a 7. If you like the number 13, find out what's the probability of 13. Just take a minute with your partner. Work. So, Francesca, can you give me one that you guys just thought about? Just saying, I don't care what number. Give me a number and we're going to figure out the probability.
8.
Probability of 8. Our probability of getting 8 would be what? How many 8s do we have on here? How many results of 8 do we get? 5. How many total results are in our table? 36, right? So we look at probability of getting an 8, 5 out of 36. What if, like the problem that we just had, Marvin, we look at the probability of getting a 1?
0.
What? How do you know that?
But you can't get 1.
It's not there. Right, so I've had students come to me, they're like, hey, this problem like doesn't make sense. It isn't there. It makes sense. It's just 0. Right? Marvin did a really good job of identifying it can't happen, so your probability is 0. If we want to be technical, 0 out of 36 because we have 36 results. What about, can anyone make an argument for, like, let's say we're going to bet again. Right? Don't gamble, but say you're betting on the dishes, something like that. What number is most likely to occur and why? What number is most likely? Ella, what do you think? Why do you think that is? Yeah, I agree that there are more 7s than any other number, but why are there more 7s than any other number? Okay, why is it in the middle of the grid? I agree. Patrick?
There's six ways for you to get a total of 7 when you roll the die.
It's the easiest sum with the numbers we have to work with. Right? You have the numbers 1 through 6. How can I add them up and make other numbers? Well, if I think about making a 2, there's only one way to do that. The 1 and the 1. But if somebody tells you, hey, make 7, you're like, oh, I got a bunch of options. So, if you're playing a board game, take it from the board game geek up here. 7s are the most likely outcome because their probability is what? What's the probability of 7 then? How many over
36.
6 out of 36, which reduces, if you want to 1/6. So we had coins, right? 2-sided coins. We got 4 results. Rock, paper, scissors, 3 options, and we got 9 outcomes. We have a 6-sided die, 2 of them, and we got how many outcomes? 36. Can anyone figure out a pattern? Francesca?
It's doing 6 times 6, 2 times 2, and it's just multiplying by the same number.
So, if the event happening, we don't have to write this down, we don't have to formalize this right now, but I want you guys to notice the pattern that we found. The event that we're doing, like 2 of, right? 2 coin flips, 2 people playing rock, paper, scissors, 2 dice getting rolled. Take the number of outcomes for each, like 6, multiply by the other one, and you get your total possible results. So here's a challenge that I want you to think about with your partner. If I gave you 1 die and a coin, how many possible outcomes are there? Like a coin to flip, like a quarter, a coin to flip, and a die to roll. And you're going to do it at the same time. Talk with your partner just for like 30 seconds. How many possible outcomes would there be? Talk with your partner. Yell out loud.
I don't know.
You're right.
Who thinks it's 6? Okay, good, because just rolling the die, there are 6 options. Who thinks it's 8? 10? 12? What other numbers? 20? 40? So wait, you get more from a coin and a die than a die and a die? Draw this in your notes real quick. Coin. Sorry, coin and oh, you're gonna split each letter. Thanks, smart word. Coin and except for the end. What are my possible results of the coin? Heads or tails, right? Heads, tails. What are my possible results of the die? 1, 2, 3, 4, 5, 6, right? A top and a bottom for heads and a tails. Heads and 1, heads and or tails and 1. Heads and 2, tails and 2. Heads and 3, tails and 3. Heads and 4, tails and 4. Heads and 5, tails and 5. Heads and 6, tails and 6. How many options or how many outcomes do we have here? 12. So here is a general rule that we can create. And I don't know how, like, we don't need to formalize it to write it down right now, but give me your eyes. Give me your attention. When we have multiple things happening, take how many outcomes from the one event and multiply it by how many outcomes of the other, and it's going to give you all possible outcomes. So coin, 2 outcomes. Die, 6 outcomes. Multiply, we get 12 all possible outcomes. Does that make sense? That's why we were doing the 2 and the 2 and the 3 and the 3, because they were the same, but they don't have to be the same. Alright, so now if we get back into the book, I went really rogue from the book for a minute. So I'll scroll back up here. Talk with your partner maybe about a minute. If Gloria and Jenny are going to face each other in rolling the die, Gloria wants a 6 to happen. Jenny wants an 8 to happen. Who has a better chance? So talk for a moment, then I'll pull from a card. So, Delaney, what do you think about who has a better chance of winning? Why? Why do you think that? Gotta back it up with math. So, like, what's the probability of getting a 6? 5 out of 36, right? What's the probability of getting an 8?
5 out of 36.
And since they are 536, 536, how do they compare? Are they equal? Is one greater? I'm not throwing gang signs. How do those fractions compare? They're equal means nobody has an advantage. Because my probabilities are equal. Hey, I don't know, I'm losing you because I threw gang signs, sorry. Here's what's up. Even though they're two different events, get a 6, get an 8, right? Like add to get a 6, add to get an 8. Their probabilities are equal. No one has an advantage. Does that make sense? Probabilities are equal. Your chances are equal. Nobody has an advantage. All right, so think about rock, paper, scissors. Could we use a table like this to help us with rock, paper, scissors and make a better table than we did yesterday? Take a moment with your partner. Try to make a better table for rock, paper, scissors. We made one yesterday, but it was kind of crummy.
Why'd you get the die from
I think there's a chance that we are going to go back, but we're going to that 5 minutes at the beginning of class, I'm still getting used to that. I was going to have you guys trial this to do experimental versus theoretical, and we were going to discuss like that experimental doesn't really come out to be the same as theoretical, but we want to. So if you roll your die 6 times, you won't necessarily get 1 7, which is what we calculated, right? Our probability. Hey, so Francesca, you can ignore me if you want, but Francesca asked, like, hey, why do we have to die if we're not going to use them? We were going to look at the fact that, so we talked about the probability of getting a 7 is 1 out of 6. Right, but if you roll your pair of dice 6 times, are you guaranteed to get 1 7? No. Difference between theoretical and experimental. So if you want to try these things out and roll dice, you're now talking about experimental. But we just thought about it. This is theoretical. So please, we're not leaving yet. I still got a couple minutes, but as you leave, please just drop your dice back in that bin. If I'm playing rock, paper, scissors versus my partner, then Allie, what are my options for what I can choose to throw? Like my results. Yeah. Like, I'm playing rock, paper, scissors. What do I choose from? Yeah, I have 3 options, right? Rock or paper or scissors. My partner chooses from how many options? Rock, paper, and scissors. 3 options. Can we anticipate how many total possible outcomes there will be inside my table? How many? How do you know that? 3 options by 3 options. When I make my grid, it's going to make 9 sections. Here is my rock. Here is my rock, paper. Here is my rock, scissors. It's the same thing we did yesterday. We're just going to lay it out differently. Here's paper, rock. Paper, 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 scissors. Scissors, rock. Scissors, paper, and scissors, scissors. Same thing as yesterday, but it makes more sense. Right? This is nicer. Jingle Bell Rocky's not on. So, thank you guys very much. Please come to class. Hey, we're doing a homework check tomorrow. So please have stuff ready. Get done through 523. We'll check through 523. No. Because we'll buy me new Smartboard pen tips, and then I'll replace them. And then I should just get on Amazon too and get some. It bothers me that the tip is mashed in on the blue pen, so I can't use it probably.